Hello there, Matayom 1 or grade 7. We are talking about the second part of this topic. Welcome to Science 1. This is Chapter 6, Heat. Topics is 6.2, Effects of Heat on Matter, but this is the second part because it's a long topic to talk about. There are three parts. So this is part B. And I want you to review this one by watching it again and again on YouTube and with your Thai translation. I'm trying my best so you can prepare for your final test. So this is now B, changes in temperature. Okay? So when some water of 80 degrees Celsius is left in a beaker on a table, what will happen to the water? Now, the hot water will lose some of its heat to the surroundings. After some time, the water will become cooler. After a much longer period, it will have the similar temperature of the surroundings. Why is that? So you see there's a heat loss from 80 degrees Celsius to becoming 25 degrees Celsius. This is the temperature of an object will drop when it releases heat. All right. Now, when a beaker of water is heated, the water will gain or receive heat. The water will become hot. Its temperature will increase. So you see in here from 25 degrees Celsius to 85 degrees Celsius. It will become hot again. This is the temperature of an object which will increase when it gains heat. Now, I want you to see this illustration right here. When two beakers of different quantities of hot water are left on a table, which is hotter after 10 minutes, water in beaker P or water in beaker Q? Answer that one. What do you think? So the increase and decrease of temperature when an object is heated or cooled depends on the mass of the object, the substance the object is made from, and the amount of energy transferred. Now, we don't have a workbook, so I want you to go directly to the next part. Now, let's talk about a specific heat capacity. So the specific heat capacity of a substance is the amount of heat required to increase its temperature of 1 kilogram of the substance by 1 degree Celsius. Different substances have different specific heat capacities. Its unit is J, kJ, all right? Here is to 1 or 1 degrees centigrade is to 1. I'll be back right away. Something is wrong with my computer. All right. In other words, its unit is joules per kilogram per degree Celsius. Remember, joules per kilogram per degree Celsius. This is per, like minus one there. Superscript minus one. Joules per degree kilograms per degree Celsius. And so, right here, look at the substance specific heat capacity. For water, it is 4,200. For copper, it is 387. Okay, I need to hide that one. For glass, it's 840 joules per kilogram per degree Celsius. And here, for mercury, it's 139 joules per degree per kilograms per degree Celsius. And gold, it's 129 joules per kilograms per degree Celsius. And iron is 452 joules per kilograms per degree Celsius. Now, hot tips. Heat capacity of a substance is the amount of heat required to increase its temperature by 1 degree Celsius or 1 degree centigrade. It is different from specific heat capacity. All right? So, for example, here, I want you to see this. Water has specific heat capacity of 4,200 joules per kilogram per degree kilograms or per degree Celsius. In order to increase the temperature of 1 kilogram of water by 1 degree Celsius, 4,200 joules of heat is needed. All right, from 25 degrees Celsius to 26 degrees Celsius, you need 4,200 joules of heat. Do you understand? So for one copper, I should say, for 1 kilogram of copper, and if you want to increase it to 20 to just 1 kilogram, you need 387 joules of heat. Is that clear now? That copper has specific heat capacity of 387 joules per kilograms per degrees centigrade. In order to increase the temperature of 1 kilogram of copper by 1 degree centigrade, you need 387 joules of heat. All right? Okay, therefore, water needs almost 10 times larger amount of heat than copper of the same mass. All right, the same mass, 25, 1 kilogram of water, 1 kilogram of copper, but they need different heat, okay, or joules of heat. Now, remember that heating substances with high specific heat capacities needs a lot of heat energy and therefore a longer time to heat up. All right? They also need a longer time to cool down. For example, the land heats up quicker than the sea. This is because the specific heat capacity of seawater is greater than that of the land. So more heat energy is needed to heat the seawater up to reach the same temperature increment as the land, and so it takes longer. The seawater also takes longer time to cool down. Well, you don't have a workbook, so no need to do that. Now, let's talk about this one again. All right? Now, let's talk about the quantity of heat gained or lost by an object is given by Q equals mc theta, where we understand that Q here equals heat gained or lost in joules, and m, letter M, is equals to mass of the object in kilograms, and small letter c is specific heat capacity in joules or in joules per kilograms per centigrade or per Celsius. And theta, the Greek letter theta, equals change in temperature in degrees Celsius or centigrade. Now, for example, how much energy must be provided to raise the temperature of 2 kilograms of water from 25 degrees Celsius to 35 degrees Celsius? That's about 10 degrees Celsius, right? So solution, mass equals 2 kilograms. Specific heat capacity of water. So we have here C equals 4,200 joules per degree kilograms per degree Celsius. So change in temperature, theta equals 35 minus 25. So you got 10 degrees Celsius. So we have here Q equals mc theta. All right. So 2 times 4,200 times 10, you get 84,000 joules. All right. Okay. You can review this one. Example 2. 1 kilogram of water with a temperature of 15 degrees Celsius is placed in a refrigerator. What is its temperature after 29,400 joules of heat has been removed from it? Solution. So mass equals 1 kilogram and so specific heat capacity of water is 4,200 joules per degree kilogram per degrees Celsius. Heat removed, we have here Q equals 29,400 joules. So Q equals mc theta. As we know the temperature is here, you're gonna convert this into Q equals uh, theta equals Q over MC. And so you have 29,400 over 1 times 4,200. And so equals 7 degrees Celsius. All right? The final temperature is 15 minus 7. And so it's 8 degrees Celsius. Okay, let's watch this video about specific capacity. Wait, I need to make sure that you hear the sound.
You might have noticed that if you are trying to boil a lot of water, it takes longer than if you only wish to boil a small amount of water. This is all because of something called heat capacity. Keep watching to learn more. Before we get into details, it is important to realize that there is a difference between heat and temperature. Temperature is a way of describing how hot or cold an object is and is measured in degrees Celsius, whereas heat is a form of energy and is measured in joules. The more heat transferred to an object, the more its temperature will rise. So heat and temperature are related, but they are not the same. So what is heat capacity? The heat capacity of a substance is defined as the amount of heat required to raise the temperature of a material by 1 degree Celsius. However, what's more useful for us to think about is the specific heat capacity of a substance. This is, as it says in the name, a little bit more specific. It is the amount of heat required to raise 1 kilogram of a material by 1 degree Celsius. Different materials have different known specific heat capacities, but we aren't always given a table like this, so we need to know how to calculate specific heat capacities ourselves. We have this equation, which can be written as symbols like this. The energy transferred is the heat energy absorbed or released. This equation can also be rearranged. To work out the temperature change, subtract the old temperature from the new temperature. Let's have a look at a problem. Pause the video and attempt to calculate the specific heat capacity of lead. How did you get on? The energy transferred is this, the mass is this, and the temperature change is 10 degrees Celsius. Because it's this, take away this. Using the rearranged equation, substitute in the values and we get 128 joules per kilogram Celsius. Here is another practice problem. Pause the video and attempt to calculate the energy transferred to the lead. Did you get it right? We could divide by 1000 to turn the answer into kilojoules. Notice that the answer is negative this time. It's because we cooled the lead. The temperature change will always be negative if it is being cooled, and positive if it is being heated. So there you have it. To summarize, specific heat capacity is the amount of energy needed to raise 1 kilogram of a substance by 1 degree Celsius. It's helpful because it allows us to work out how much energy we need to heat up or cool down a substance to a desired temperature. To calculate it, use the following equation.
Please like and share our videos with your friends. If you have any questions that you want help with, just comment below.
All right. Now that you have watched it, it's time to go to your workbook, which you don't have right now, but we go directly to the application of specific heat capacity. Cooking pots and kettles are made of metals with low specific heat capacity so that they need less heat to rise up the temperature. However, The handles of cooking pots and kettles are made of materials with high specific heat capacities. All right? So we have this material with a low specific heat capacity, and this one is with a high specific heat capacity. All right? So these are parts of a pot with different heat capacities. Now, car radiators use oil, I should say, car radiators use water as the cooling agent, as water has a high specific heat capacity. So the water is pumped to circulate, all right, around the engine. The heat produced by the engine is absorbed by the water. The water then travels to the car radiators where the heat from the water is released through the cooling fan. All right? So this is heat removed from the engine. You see the energy given out by the radiator. You'll understand how the water travels around the engine that cools the engine. All right? This is the car radiator. Now, sea breeze and land breeze are formed due to the differences between the specific heat capacities of land and sea water. Land has a lower specific heat capacity than that of the sea water. In the daytime, the land heated up faster than the sea. The hot air above the land rises and the cooler air from the sea rushes toward the land, producing sea breeze. You see that? All right. Now, as we understand this one, we become better. However, at night, the temperature of the land drops faster than the sea water. The hot air above the sea rises. The cooler air from the land rushes toward the sea, producing land breeze. You understand why you have a land breeze? Is because of different temperature between the land and the sea. Now, land and sea breezes. You can click more on here, which we do not need this time. So let's watch this applications of high specific heat capacity of water. All right?
Applications of high specific heat capacity of water. The quantity of heat required to raise the temperature of unit mass of a substance by 1 degree Celsius is called its specific heat capacity. The specific heat capacity of water is 4200 joule per kilogram degree Celsius. Thus, 4200 joule of heat is required to raise the temperature of 1 kilogram of water by 1 degree Celsius. There are several applications of high specific heat capacity of water in everyday life. Formation of land breeze and sea breeze. The specific heat capacity of water is about 5 times more than that of sand. During daytime, sand gets heated more quickly compared to water. The air layer associated with sand becomes hot and rises up. This causes the sea breeze to move towards the land. During night, as the sand cools much faster than water, the air layers above the water are hotter than the air layer above the sand. Therefore, they rise up and land breeze moves towards the sea. Hence, a moderate climate is maintained near the seashore. Fermentation. As water has high specific heat capacity, it absorbs a large amount of heat when its temperature rises. Also, when the temperature decreases, water gives out large amount of heat. Due to high value of specific heat capacity, water takes longer to cool down. For this, we use water in hot bags for fermentation purposes. Coolant. Water is used as an effective coolant by letting it flow in pipes around the heated parts of a machine. Example, radiator of a car. When there is a rise in temperature, Water extracts more amount of heat owing to its high specific heat capacity. To avoid freezing, in cold countries, wine and juice bottles are kept underwater to avoid freezing because water does not cool quickly owing to its high specific heat capacity. Did you know? The high specific heat capacity of water regulates the extremes in the environment. For instance, in ponds, the heat capacity of the water helps regulating the temperature of the water and keeping it relatively the same from day to night. Protection of crops. Farmers protect their crops from frost by filling the fields with water during winters. Since the specific heat capacity of water is high, the temperature of water does not decrease much on a cold night. Thus, it does not allow the temperature of the surrounding area of the plants to decrease. Metals like copper, aluminium, iron, etc. are good conductors of heat, and they have low specific heat capacity. Therefore, cooking utensils are made up of these metals so that they can quickly attain a high temperature for a known quantity of heat supplied. Specific heat capacity is the quantity of heat required to raise the temperature of unit mass of a substance by 1 degree Celsius. The specific heat capacity of water is 4200 joule per kg degree Celsius or 4.2 joule per gram degree Celsius. Due to high
Wait.
heat capacity of water, land breeze and sea breeze are formed. Water is used in fermentation bags because of its.
All right, that's enough. Okay, so we go to the next one here. Take note that this is the second part of this lesson, so wait for the next video.